All right, so pre-calculus students, this is a video for sections 1.4 and 1.5. These two are tied very closely together. I'm going to be putting this video out because in my 8:30 class, had some technical laptop issues, and then I had every other issue in the book, including my own stupidity, so I made some errors. I want to provide this supplement for you guys. There's going to be more examples, better examples for you guys. And then to my 11 o'clock class, I apologize for having to cancel so early. Sorry, so late in the game. But I'm going to provide this video for everybody so that we can progress in the class, and I can provide plenty of examples for you guys. So when we're solving quadratic equations, there are really four main methods. And we've got methods 1 and 2 are in orange, and they're in orange because these two methods will not always work. They pretty much have to be set up in such a way for these two methods to work. The green methods always work. Notice that completing the square has an asterisk next to it, and that's because honestly, it is not a method that I use very often or at all when I am solving a quadratic equation. Really, the only time I ever use it is when I have to teach it. Now, that doesn't mean that completing the square is not a necessary skill. Getting the skill of completing the square is going to be useful when we get to sections 2.2 and 3.1. So I would suggest practicing it at the very least. So let's dive in here to the zero product property. The zero product property says that whenever two numbers are multiplied together, that one of those two numbers has to be equal to 0. Okay? And 0 is the only number that works with. So what it's saying is, if A times B is equal to 0, then either A has to be 0 or B equals 0. That's the only way that we can get an answer of 0 over here. So how's that going to apply to these problems? Let's first look at number 1 here. And on number 1, I've got x squared minus 5x plus 6 equals 0. If I am wanting to factor this, I'm looking for the factors of a positive 6 that add up to get me a negative 5. And so that will be a negative 2 and a negative 3. And so now I've got the left side of this equation factored. So I've got something times something else equals a 0. So this is when this zero product property is going to come into play, because we're going to set each of these two factors equal to 0. Okay, now let me say this only works because that number is a 0. If it were a 4, it doesn't work. It only works if it's a 0 over here. So we set each of the two factors equal to 0, and we will get our two solutions of a 2 and a 3. Okay, now here's some things that I want to highlight here. I got two answers. Okay, so why did I get two answers? Well, I got two answers because my highest exponent is a 2. Okay, when you're dealing with polynomials, the degree of your polynomial is going to tell you how many possible answers you should have. Another thing here is this idea of solution. Okay, so what this means is these numbers are going to give me a true statement. So I'm going to type this in actually up here. A solution is a number or numbers that make the original statement true. And we'll talk about that with one of these values. So let's take the 3, for instance, okay? So 3 squared minus 5 times 3 plus 6, okay? Does this get me a true statement? Okay? So whenever I simplify all of this, I end up getting a 0 equals a 0, which is a true statement. So that's why 3 is a solution. Now, if I went back in and put 2 in as the value for x, it would also get me a true statement. So these are our two valid solutions. Now, that idea is going to come up fairly quickly after we take our first test. So I wanted to highlight the definition of what a solution is. Okay. All right, so on number 2 here, I've got 2x squared minus x minus 15 equals 0. So I'm going to, well, first of all, there are a lot of different methods to factoring these things. This is the method that I choose to use. So if you are not comfortable with this method and you are comfortable with an alternative method, then use the one that you're comfortable with. All right. So for me, I'm going to say, all right, so 2 times negative 15, all right, that gets me a negative 30. So what are the factors of a negative 30? So here are our list of factors. And I want the factors that get me a subtraction, or sorry, an addition of a negative 1. So the factors have to multiply together to get a negative 30. And the only way to get a product of a negative is for one of your two values to be negative. So I'm going to use a negative 6 and a positive 5. All right. Negative 6 times 5 gets me the negative 30. Negative 6 plus 5 gets me the negative 1 that I need right here. So what I'm going to do is I'm going to separate out this first term, and I am going to factor by grouping now. Okay. So the GCF of the first two is going to be a 2x, and that leaves me with an x minus 3. The GCF of the second two is a 5, and that leaves me with an x minus a 3. And so notice that these two factors are the same. So x minus 3 is one of my factors, and then 2x plus 5 is my other factor. So now I'm back to what I was talking about of having two factors that are multiplied together, and the answer is 0. So I'm going to set each of those equal to 0. So x minus 3 equals 0 gets me a solution of 3. And 2x plus 5 equals 0. If I solve that one, 2x equals a negative 5, divide by the 2, and so I get negative 5 halves for the second solution. Okay. All right. So that's the first two. Let's go ahead and look at the third one here. Let me draw a line. And number 3, we've got negative 4x squared plus x equals a negative 3. So I'll scroll down here, give myself some more space. All right, so notice that this does not equal 0, and I need it to. So I'm going to add that 3 over. And so now this is what my equation looks like. But I will tell you that I am not comfortable factoring whenever my first term here is a negative. Okay, so what I'm going to do is I'm going to multiply the entire equation by a negative 1. And that gets me a positive coefficient for my x squared term. Okay, so now we're going to factor this just like we did the other one. Okay, so 4 times a negative 3 is a negative 12. So the factors of 12 are 1 and 12, and 2 and 6, and 3 and 4. So I'm going to use a positive 3 and a negative 4, because positive 3 times a negative 4 is a negative 12, and positive 3 plus a negative 4 gets me this negative 1 that I'm wanting here. So I think I'm actually going to rearrange this a little bit. I'm going to make it a negative 4x and then plus a 3x minus a 3. It's going to make my factoring just a tad bit easier here. So if I factor the GCF out of the first two, I get 4x, and I'm left with an x minus a 1. If I factor my GCF of the second two, it's a 3, and I'm left with an x minus 1. Notice again that the x minus 1s are the same, so that's my first factor. My second factor is the 4x plus the 3. So if I set each of these factors equal to 0, I'm going to get a 1. So this is one of my solutions. And if I set 4x plus 3 equal to 0, subtract the 3 across, divide by 4, and I get a negative 3/4. All right, so this is using the zero product property and factoring. Okay, so that is this first method listed up here. Okay, that's this one. The next one is a square root property. Okay, so a square root property is going to look like one of these. Okay, I just realized that the examples that I picked to do in my 8:30 class are very much like these. I think 1 and 2 I already did in class, and I think 1 and 2 up above this I did as well. So if I look at number 1 for the square root property, notice that what I've got is a quantity that's squared equal to another quantity. So I can take the square root of both sides. So the square root of 4 is both a 4 and a negative 4. Those are my two solutions. Now, remember what the word solution means. A solution is a number or numbers that make the original statement true. If I put 4 in for x, this is a true statement because 4 squared is 16 and 16 equals 16. If I put negative 4 in for x, okay, let's make that look like a negative 4. If I square a negative 4 that's in parentheses, I also get 16. So these are both true statements, which means that these two things are both solutions to my equation. So whenever you're using the square root property, you need to remember that you are going to be taking both the positive version and the negative version of the square root. So let's look at number 2. X squared plus 54 equals 0. So I don't have the squared thing by itself. Okay, so here's how this one is different than, say, these up here. Notice I had a square. These have squares and x's. Okay, because these have squares and x's, I can't just go straight to using that method that we were using up there. So because I only have an x squared term, I'm just going to subtract the 54 across. And then when I go to take the square root, I need to simplify this. So I'm taking the square root of a negative number, which means that my answer is going to have an I in it. Okay, so 54, that's going to be a 9, a negative 1, and a 6. So the square root of 9 is 3. The square root of negative 1 is I. And the square root of 6 I have to leave alone. So this is one of my answers. My other answer is the negative version of that. Okay. All right, moving on to number 3 here. So number 3, yes, it does look different, but notice that I've got something squared equal to another value. Okay. On number 2, I had to fix this by getting the 54 over, but on numbers 3 and 4, I'm not going to have to do any of that. So if I take the square root of both sides, the square root of 3x minus 1 quantity squared is 3x minus 1. The square root of 12, I can simplify that because that's 4 times 3, so that'll be 2 rad 3. But remember, it's going to be 2 rad 3 and the negative version of that, negative 2 rad 3. So I'm going to solve this one over here. I'm going to add 1 to both sides. So that'll be 3x equals 1 plus 2 rad 3. And then I'm going to divide both sides by 3. So I get 1 plus 2 rad 3 over 3 for this answer. Now notice when I go through the steps over here, how similar this is going to look. Whoops. Let me erase that. Okay, so look at my two answers here. Essentially, the only difference between these two answers is the sign that is in between the 1 and the 2 rad 3. Okay, one of them it's a plus and one of them it's a minus, and that's the way it's going to work with these. Okay, if you have either complex or irrational roots, they're going to come in pairs and they're going to be conjugates of each other. That's what those things are called, and we'll talk more about that when we get into chapter 3, when it's a little bit more important of a topic. So if I look at number 4, again, it's set up except for when I go to take the square root here on the right side, I'm taking the square root of a negative number. So it's going to be I rad 6. It's also going to be equal to negative I rad 6. But let me show you what I'm going to do here. I'm just going to find one of my solutions here. So 4 plus I rad 6. And then I'm just going to know that also 4 minus I rad 6 is going to be an answer. Okay? They're going to be conjugates of each other. That's the way that's going to work out. Now, what we've just done is we've done the two orange ones up here. Okay? And remember, these two do not always work. Okay? You have to be able to factor to do number 1, and it needs to be set up to do number 2. Okay? You've got to have something squared equal to something else, and they're not always going to be set up that way. So let's look at these, and we're going to do these by completing the square. Now, I will tell you, again, that whenever I'm doing this work, the only time I ever really do completing the square is when I'm teaching it. Okay? Other than that, I don't do it. But I would say that this is an extremely important skill that you're going to want to use, because when you're doing this, hold up momentarily for just 1 second. Okay. Yeah. Whenever you're, I'm going to start that all over again. For a second, my little screen recording thing went away, and I wasn't positive that I was recording at that moment. So I don't use completing the square, but it is an important skill. When you go to doing circles and the vertex form of a quadratic equation that you're going to graph, you're going to want to be able to know how to complete the square. It's just kind of complicated and not really worth it. On the first one, it's not going to be that difficult because it's set up in a nice, easy way. So in order to complete the square, you need this coefficient in front of your x squared term to be a 1. And in numbers 1 and 2, it is. We'll talk about what to do when it's not on number 3. So because this is a 1 right here, what I'm going to do is I'm going to go ahead and add that 9 across. Now notice that I left this space here. Okay? I'm leaving this space here because my next step in completing the square is going to be taking half of this term and squaring it. Okay? Now in my first class, this is one of the mistakes that I made. I didn't balance out the equation. Okay? If you add something in on one side, you have to add something in on the other side. All right? So now, whenever we go to factor this, This completing the square process guarantees me that it's going to be that variable and the number that I squared. Okay? So it's always going to fall into that form. All right? Over here, 3 squared is a 9, so 9 plus 9 is an 18. Now, I've got this set up like one of these. Okay? So even though I'm going to end up using the square root property, it didn't start off looking like I was going to. Okay? So the square root of the quantity x plus 3 squared is x plus 3. The square root of 18 is going to simplify. That's going to be a 3 rad 2. Whoops. All right, and just to drive the point home, it's the positive and the negative version. So then if I subtract the 3, it's going to be negative 3 plus 3 rad 2. And on this one, it's going to be negative 3 minus 3 rad 2. So again, notice that these two things are very related. They are actually conjugates of each other. That's the name for them. So for this next one here, this one is going to play out just a little bit differently because of this 9 right here. Okay, so again, the first requirement is that this coefficient needs to be a 1, and it is, so we're good to go there. So I am going to take that 1 and subtract it over. Okay. Now here's what's different. Whenever I am going to add in this squared term here, when I take half of a negative 9, it's going to be a fraction. And that's not going to be very nice. Okay. So my factorization over here is going to be fairly easy though, because it's going to be the variable and the number that I squared. Over here, if I square a negative 9 over 2, that's an 81 over a 4. And so if I want to add these two things, I need to write negative 1 as a fraction with 4 as the denominator. So it's going to be a negative 4 over 4. So that's going to get me a 77 over 4. And then when I take the square root of both sides, I get x minus 9 halves equals, the square root of 77 doesn't simplify, but the square root of 4 is 2. And remember, I also have, the negative version of this hanging out over here. So when I add the 9 halves across, my two answers are going to be a 9 halves plus a rad 77 over 2 and a 9 halves minus a rad 77 over 2. All right. And that's not the only way that you can write those, but that's probably the best way to write those. Now, you can see that this is fairly involved work, okay? Basically, you're seeing why I don't use this method, okay? But again, I would say it's a smart idea to practice this method when you're in this section so that you can know how to do it when we have to use it, okay? So this is the one where I was talking about where we do not have a coefficient of 1 here. So what we're going to do, I'm going to do two things. I'm going to factor out the 2 from these first two terms, and then I'm going to subtract the 3 over, okay? So now what I've got is inside parentheses here, the square root, sorry, this squared term does have a coefficient of a 1. So I'm going to change colors here like I've been doing consistently. So I'm going to add in half of this number squared, half of that number squared. And I've got to add it in over here too, but notice that I put this 2 here. Why am I doing that? I'm not just adding in this quantity. If I distribute this, I'm adding in 2 times that. Okay, so I mean, this is getting really crazy, isn't it? I mean, you can see why this just isn't the preferable method. Okay, it's not really intuitive or easy. So this is going to be a 9/4. So it will be a 9/2 when I multiply it by the 2. Okay, so I'm going to speed along here because I think that you guys are seeing why this method is not very friendly. Okay, so I now need to divide by the 2, which is the same thing as multiplying by a half. And so this will be a 3/4. And then when I take the square root of it, I get x minus 3/2 equals rad 3 over 2. Because you can't take the square root of 3 and get a nice neat number, but the square root of 4 is 2. So then when I add this 3/2 across, one of my answers is going to be 3/2 plus rad 3 over 2. The other one will be the conjugate of that, minus rad 3 over 2. Okay, I would say this. If I were looking at one like number 3 on a test, and the directions said specifically to solve this using completing the square, I wouldn't do that, okay? Because I want to make sure that I get it right. There's a lot of room for error in here, okay? I would use the quadratic equation, all right? Now, I'm saying that in the context of a test, all right? When you're talking about the homework, go ahead and try. See what you get, okay? Otherwise, we're going to use this quadratic formula here. And I've got 4 examples here that we're going to go through. The quadratic formula says that the solutions of the quadratic equation ax squared plus bx plus c equals 0, where a is not a 0, are given by this quadratic formula. Okay, negative b plus and minus the square root of b squared minus 4ac all over 2a. Now, I know that this looks like it's more complicated, but I promise it's way less complicated than this right here. All right? So let's look at number 1 first of all, and let's talk about why we can't factor it. Oh, wait, we can factor this one. My bad. So you might look at the factors of a negative 21, and you might not recognize that you can actually, you can actually factor this one, okay? So I'm going to use a negative 3 and a positive 7. So this is x minus 3 and x plus 7 equals 0, all right? So I'm going to get an answer of a 3, and I'm going to get an answer of a negative 7. So let's kind of know in the back of our mind here that x equals a 3 and a negative 7. All right? Because we're going to pretend we didn't recognize that we could factor that. And if you don't recognize that you can factor something, and you don't really want to complete the square, then your last option is going to be to use this quadratic formula right here. All right? So I'm going to identify a as a 1, b as a 4, and c as a negative 21. So I'm going to substitute this into the quadratic formula. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so that's just substituting. Really what we've got here now is just like a really long drawn out order of operations problem. So the negative of 4 is a negative 4. 4 squared is a 16. And the denominator, 2 times 1 is 2. So if I multiply negative 4 times 1, I get negative 4. And then negative 4 times the negative 21 is going to get me an 84. And so if I add the 16 and the 84, I'm going to get a 100. Now, if you get a perfect square right here, all that means is that you could have factored this problem, okay? Because now what I've got is a negative 4 plus the square root of 100 is a 10 divided by a 2, and a negative 4 minus a 10 divided by 2. And when we play this out, this is going to give us our two answers of a negative 3 and a positive 7. So essentially what has happened here is we did not recognize that we could factor this. So we ran through the quadratic formula and we got two nice, neat integer answers. Okay? But if we look at number 2 here, 2 is not one that can be factored. Now, first of all, we've got an issue here. This is not equal to a 0. So I'm going to subtract the 2x across and add the 5 across. And now this gives me my trinomial that I'm going to work with. Okay? I can't factor this. There aren't factors of 5 that add up to get me a negative 2. So I'm going to identify a as a 1, b as a negative 2, and c as a 5. And I'm going to use this handy-dandy quadratic formula again. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. All right. Now the ones that don't factor don't end up going as far as these, okay? The ones that would factor go, they use all of these steps, but not this one. So the opposite of negative 2 is a positive 2. Negative 2 squared is a 4, and negative 4 times 1 times 5 is a negative 20. In the denominator, 2 times 1 is a 2. So underneath this square root, I get a negative 16. Now, when I take the square root of a negative 16, I actually get a nice, neat value. I'm going to get a 4i. Now, you shouldn't leave your answer in this form because it's not in the a plus bi form. Notice here that all of these numbers are divisible by 2, which means that this really is 1 plus and minus 2i. Now, if MyLabs Plus gives you the availability, excuse me, of a plus and minus button, then you can use this as your answer. Otherwise, you're going to need to separate these two out, and it'll be a 2 plus an I. Sorry, it'll be a 1 plus a 2i and a 1 minus a 2i. I misspoke there. All right. Let me get some more space here. And I want to go up here and grab number 3. So it's negative 6x equals 3x plus 2, and then number 4. Oh, I bet you guys are looking forward to doing this with fractions. You're probably looking at that one, thinking very bad thoughts of me. But I will save the day, I promise. Okay, so number 3. We've got negative 6x squared equals a 3x plus a 2. And so, we want this to be equal to a 0. So we can subtract the 3x across and subtract the 2 across. All right. The other thing that I'm going to do here is I don't really like my a term to be a negative. So if I multiply the entire equation by a -1, now this looks a lot nicer. Okay. So I've got an a is a 6, a b is a 3, and a c is a 2. So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. All right, here. 3 squared is a 9. Negative 4 times 6 is a negative 24 times 2 is a negative 48. And then in the denominator, 2 times 6 is a 12. So, let me move that out of the way here. When I subtract 9 minus 48, I get a negative 39. Okay? Well, that's not a very nice, neat number. That's going to get me an I. But the 39 I'm going to have to leave in here. Now, I believe that MathLab is going to make you split this up into a nice, neater answer. So, because they want the a plus bi form. So negative 3 over 12 plus and minus rad 39 over 12i. And then you can simplify that. So it would be negative 1/4 plus and minus rad 39 over 12i. All right. Now, this does look fairly complicated, but let me tell you, it is way better than the alternative here. Okay, this method with number 3 is really crazy difficult to do. Now, I know that you've been looking at number 4 with those fractions, and you've been thinking, oh my goodness, what are we going to do here? But there's something very simple and direct that we can do to make this one a heck of a lot easier. And what we're going to do is we're going to multiply the entire equation by the least common denominator. The denominators are a 2 and a 4. So the least common denominator here is a 4. And when I distribute this, this will be a 2x squared. This will be a 1x. And this will be a negative 12. And so now I've got a nicer, neater looking problem to do the quadratic formula with. I'm not having to use the fractions, okay? So A is a 2, B is a 1, and C is a negative 12. So that's going to make things a heck of a lot easier. So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so 1 squared is a 1. Negative 4 times a 2 is a negative 8. Times a negative 12 is a positive 96. And 2 times 2 is a 4. So if I look at this, let's see here. That's a 97 over a 4. 97. I don't think we can simplify 97. Yeah, we're done here. Okay. So that is using the quadratic formula. Okay. That's what we're going to do when we use the quadratic formula. So the easy adjustment when you see fractions there is just to multiply everything by the least common denominator, and that's going to help you out for this. Okay. Now we've got 2 application problems that we're going to do here. Whoops. Sorry about that. Need some space here. All right. So this is where we switch over into section 1.5. 1.5 only has 5 problems in it, and they are applications of what we just did. So let's look at this one. It says, an ecology center wants to set up an experimental garden using 300 meters of fencing to enclose a rectangular area that is 5,000 meters squared. Find the dimensions of the garden. So if we're going to be looking at area of a rectangle is length times width. Okay? And they've told us that the area of this rectangle is 5,000 meters squared. And if we look here, I've got a length of 150 minus x and a width of x. Now, where do these two things come from? Okay, so we know that the lengths and the widths have to be equal to, the 2 lengths have to be equal to each other and the 2 widths have to be equal to each other. And so we're playing this 300 against that. So if I've got an x here and an x here, that means I've got enough for 150 minus x and 150 minus x here. Okay, I'll show you how all this plays out whenever we are finished. So to solve this, the first step is going to be to distribute. So we'll get 150x minus x squared. And we want to get all of this where there's a 0 either on the left or the right. I'm going to want to get the 0 on the right, so I'm going to add the x squared over and subtract the 150x over. And then I've still got this 5,000. Okay. Now at this point, you can look at this and say, you know what, I think I want to factor that. And you can. Okay. You can go for that. You could complete the square. Although I don't really know why you would, you could want to do that. You could say, you know what, I don't really want to try to factor this. I want to use the quadratic formula. Any of those methods are going to be fine. Okay. But, let's just go for factoring because I think we're going to be able to do this here. So I want to add up to a negative 150. So it's 1 and 5,000, which is 2 and 2,500, which is 4 and 1,250, which is 8 and, good night, what happens if I have that? I get 625. Okay, so we're done right there. This is also 5 and 1,000. So it would be 10 and 500. It would also be 20 and 250. It would also be 40 and 125. It's also going to be 10 and 500. Let's see here. Why am I not seeing this factoring here? Oh, because it's also going to be 150. There we go. Ding, 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 ding. So this is going to be x minus 100 and x minus 50. So if I set each of these equal to this 0 here, I'm going to get two answers. But one of them actually isn't going to work out in the context of the problem. Okay? Remember how much fence we have. We have 300 meters. Okay? And I need 2 lengths and 2 widths. So what I just found was, well, if there's 100 left over right here, okay, well, I guess we kind of found both answers, didn't we? If there's 100 for this width and 100 for this width, that means the length only has 100 left to divide between both of them, okay? So that's one way that we're going to find these dimensions. The other way is with the 50, and it's essentially the same thing, okay? So I know I've got 300, I need 2 lengths and 2 widths. So if the widths are each 50, then that means I've got 200 left over. You kind of see what we're looking at here. We get the same thing both ways. We get the same kind of dimensions. So the question asks, find the dimensions of the garden. It'll be 50 meters by 100 meters. All right. I'm going to switch to my color here for this problem. And we've got a projectile. Now this is a very classic problem from physics. Okay, we've got a rocket. A projectile, we'll call it a rocket. It'll just make it easier. A projectile rocket is launched from the ground level with an initial velocity of v sub 0 feet per second. Neglecting air resistance, its height t seconds after launch is given by this formula. All right, so here's the scenario. We're launching this thing up. It's going to go up, and then it's going to stop, and it's going to turn around and come back down to the ground. Okay? Now this is going to follow this quadratic formula here. This is what's going to model it. Really, there is an initial position here. But our initial position is 0 because we are firing this thing from ground level. Okay? Now, if we were like up on a building and shooting it up in the air and then letting it go to the ground, this would be a different value. Okay? So find the times that the projectile will reach a height of 160 feet and return to the ground when this initial velocity is 112. So here is the equation that we are going to use to model this projectile. Okay? So part A asks us, well, when is this thing going to be 160 feet off the ground? Okay? So what they're saying is, well, this height here of 160, when does the projectile get that high? And you can see that it might get there twice. Okay? Now this line could actually be up here and it only gets there once, or it could be up here and it never gets that high. But in ours, it is going to end up getting that high. So I want to make one side equal to 0. I'm going to go for the right side because I want this 16 to be a positive. So I'll add the 16t squared across. I will subtract the 112t, and I will keep the 160 over here. Now this looks terrible in the way of factoring, but the good news is we've got a GCF here of a 16, which means that we're only going to be left with t squared minus 7t plus 10. Okay. Now remember my zero product property. If two things are multiplied together and the answer is 0, one of those two things has to be a 0. Well, 16 cannot be equal to 0. So really, I'm just going to try to factor this. So this will be a t minus a 5 and a t minus a 2, because -5 and -2 multiply together to get me a positive 10, and they add together to get me a -7. So if I set each of these two things equal to 0, I get, whoops, got a little bit over excited there. Finished the problem just a little bit too early. So we get a time of 2, which is this one. This is t equals 2. And a time of 5, which is here, t equals 5. So the rocket launches. After 2 seconds, it hits 160 feet. It reaches its maximum height. And then after 5 seconds, it reaches 160 again. And then it's going to come down and hit the ground. So part A is when does it get to 160 feet? And so that is at 5 seconds and at 2 seconds. Part B is when does this thing return to the ground? Now, when we're wanting to know when it returns to the ground, well, ground position is position 0. Okay, 0 feet off of the ground. And again, this might look intimidating to factor here, but it's not, because there is a GCF. Okay, the GCF is a 16t, which a negative 16t, which leaves me with a negative 16t times a t minus a 7. So if I set each of these two things equal to 0, I get t equals 0 here. Well, guess what? That's not my answer, because that's when I started. Okay, that's what this is. Okay, so this is not the one that we want. This one is the one that we want. 7 seconds. It hits the ground. It returns back to the ground after 7 seconds. All right. So that's these two sections. Solving quadratic functions and their applications. On Thursday, we are going to be going over the study guide. I'm not going to be able to cover the entire study guide. I won't be able to do every single problem. So don't think that that's going to happen. My best advice to you is to get in the study guide and try it at least once, and come Thursday knowing specific questions that you want to ask me. All right? So this is about it'll end up being just under a 55-minute video for you guys. Hopefully this, along with the other video that I have on my YouTube channel, is going to be good for you guys. Sorry about the technical difficulties from today. I will see you guys on Thursday.